Hello everyone. Here's a tricky change to do with unit A4 in IB physics. Oh no, my bad, it's B4. Unit B4 in A-level physics, which is thermodynamics. And we're looking at cycles of changes, usually in engines, where we get isothermal, isovolumetric, adiabatic, and I've forgotten the last one off the top of my head, but never matter. Today we're looking at adiabatic changes, and there's two equations which kind of give you a hint at the reason why isothermal is not as steep as adiabatic. So isothermal changes involve basically the ideal gas law, all right? And because the P times V is equal to a constant, uh, which in the ideal gas law would be nRT or capital N kBT. When we look at the adiabatic change, it's steeper, principally because of this factor here, this 5 over 3. So you're naturally going to get, owing to that function, we're going to get a steeper curve in adiabatic change. That's always a good hint. So this is the equation that we're going to use to solve this problem. During an adiabatic change, the temperature quadruples. By what factor does the volume change? Okay, so you need to figure out what is going on here. So a couple of different equations involved. So pause the video and then try and solve it afterwards. All right, well, we're going to go through the solution. Here we go. So So we're going to start with this equation and we're going to throw the ideal gas law at it, PV equals nRT. And what we're going to do is we're going to rearrange the ideal gas law to give us P equals nRT over V. That means we can substitute for P in the first equation. So those are the same P's there. And now we've got nRT over V multiplied by 5 to the third power of V equals a constant. Now, because this V on here is effectively equal to 3 over 3, we can actually cancel out 1V there, and that leaves us with nRT V 2 over the third, to the power of 2 over the third power. That equals a constant, and because n and r are also constants, we can sort of chuck them on the right side of the equation there, lump them in with the other constants, and this gives us another really useful equation which crops up fairly regularly in IB papers. From there, we're going to go and start thinking about this quadruple the temperature. So we're going to take this equation and we're going to see what happens before and after when we quadruple the temperature based on this equation. So because it's an adiabatic gas, it's a little more complex in terms of math. So when we rearrange this and move V over to one side, that gives us T2 over T1 equals V1 over V2 to the power of 2/3. We're interested in kind of what happens to the volume. So what we can do is switch that factor across to the other side, that power, to give us 3 over 2. So V2 over V1 is the kind of the factor we're interested in. By what factor does the volume change? So the temperature quadruples, so T1 over T2 is 1 over 4. T2 is 4 times bigger. From there, cancel out the T's, so we're left with just the numbers. And that gives us a little bit of math we can punch into our calculator and ends up with a factor of 2.52. There you go.